Hi, I'm Caroline, and in this video I'll show you exactly how to use masses of reactants or products to calculate the molar ratio and part of the balanced equation. The trick is to slow down and follow the same steps every time, and there's one really important tip that will make all the difference. If you found this breakdown helpful, then give the video a like and subscribe now for more. And check out my playlist on chemical calculations because it all links together. Let's dive in. So calculating a reacting ratio is not as common a question as some others in this topic, but it means that it's one that's easy to skip over. So let's get super clear on how to do it. It utilizes the skills from all of the other calculations. So if you haven't watched the video on reacting mass calculations, that's one to go back to now, and I'll talk you through it step by step in terms of the method that I use there. So normally you're given the reacting ratio in a question, right? If you write a balanced equation, that is the reacting ratio. Like one of these reacts with two of these, etc. Here, we're flipping that skill on its head and saying, we know in a reaction that we have the mass of this, the mass of that, and it's making the mass of this. Let's work out the reacting ratio from that and therefore the balanced equation. So it is these two steps all the time. So this method doesn't change. If you remember these two, we'll get there. So the first thing you do is you list the substances in the question along the top. And I'll show you this in the worked example next. Then you will find the moles of those substances. So put in the masses from the question, divide by the MRs, and that will give you the moles of all of the substances. Now, at that point, it is actually a ratio. But it's not necessarily a very nice ratio. It's not necessarily a whole number ratio. Like who wants to work with a ratio that's times 10 to the minus 3 something or other? So what you do at that point is you take those numbers that you've worked out, those number of moles, and you divide by the smallest number. Divide each of those numbers by the smallest number. And that is going to get you to the simplest whole number ratio. So that will get you to your 1 to 3 to 1, 1 to 2 to 2, etc., whatever that ratio is. Be careful though. If you do that and you get a half number, you can't round that up. So let's say you've done these two steps, you divided by the smallest number, and you get the ratio come out as 1 to 1.5. You cannot round that 1.5 up to 2. It's just too far away. You can't make up half a molecule. You can't magic that out of thin air. So if you were to come out with like 1 to 1.5, you need to double up both of those numbers. So the ratio would become 2 to 3. So just occasionally, there is an extra step there that once you've divided by the smallest number, you may need to multiply up in order to get the simplest whole number ratio. Let's have a look at a worked example now. Okay, so we're going to start off by popping in the numbers that we know from the question. So we have two substances, propane and oxygen. I'm going to set up my normal table, and it's normal because I teach the same method to do reacting mass calculations, to do limiting reagents, to do concentrations, etc. If that's new to you, you could always go back to those videos and I'll talk you through them step by step. So the mass of the propane is 2.2 grams and the mass of the oxygen is 8 grams. To work out the MR, then we do 3 times 12 for the carbon plus 8 times 1 for the hydrogen, and that gives us 44. And for the oxygen, it's 16 from the periodic table, it's O2, so that makes it 32. In order to work out the moles, we do mass divided by the MR is equal to the moles, and that gets us here to 0.05 and then 0.25. At this stage, we're going to add another row, so we're now going to divide by the smallest number. Now, it's so common here that actually we get the smallest number wrong. So have a really good look and check that you understand where the decimal places are to really work out what the smallest number is. So it's 0.05 here. Let's divide everything by 0.05. And this is going to get us to the simplest whole number ratio. So that works out as 1 to 5. And that's our ratio. We could put that into the equation. So that means C3H8, no number because we worked that ratio as 1, plus 5O2. That's what it would start to look like for a balanced equation. And that's your answer, ratio of 1 to 5 for propane to oxygen. Okay, so starting off by listing the substances at the top, we've got the silver carbonate, and that's going to make the silver oxide and the carbon dioxide. My table has mass, MR, moles, and dividing by the smallest down that left-hand side. Let's fill in the numbers from the question first. So 0.920 grams of the silver carbonate, 0.773 grams of the silver oxide, and 0.147 grams of the carbon dioxide. Now let's work out the MRs. So for the silver, if we look at the periodic table, its relative atomic mass, is 108. So we have two of those, 2 times 108, plus 1 carbon, 112, and 3 oxygens, 3 lots of 16. Add all of that up together to get 276. 2 times 108, plus 12, plus 3 times 16. Do the same here. 2 silvers, 2 times 108 plus 16 for the oxygen gives you 232. And the carbon dioxide, 1 carbon, 12, plus 2 lots of oxygen, 2 times 16 is 44. Now popping those numbers into the calculator. So remember that mass divided by MR is equal to moles. So there we get 3.3 recurring times 10 to the minus 3. Here we get 3.3 times 10 to the minus 3. And here we get 3.3 times 10 to the minus 3. Now that is technically a ratio, but it's not a very nice one. So hopefully you can see that, but if not, you can always process it this way by divide by the smallest number. And if we do that all the way across, then we get a 1 to 1 to 1 ratio. So if we were to determine the balanced equation there, the silver carbonate turns into the silver oxide and carbon dioxide, and they are all in a 1 to 1 to 1 ratio. So I don't need to put any other big numbers in there. That is the balanced equation up at the top.
Thanks for watching, and if you found this helpful, then don't forget to check out the other videos in this playlist and hit like and subscribe now so that we can boss chemistry together. Let's do this.